Okay, so I'd like to go to over 47 because I would imagine that if there's one that you had trouble with, I'm guessing that 47 would be it. So number 47 says a stone is thrown vertically upward with a speed of 12 meters per second from the edge of a cliff 70 meters high. How much later does it reach the bottom of the cliff? What is its speed just before hitting? What total distance did it travel? So I know that there's a diagram in your book, but I want to draw one just so that we can get the important information here. So we're throwing this up and then down. Pardon me drawing on this computer. And we know here at the beginning that we're going 12 meters per second. That's supposed to be pointing up. And the question is, how much later does it reach the bottom of the cliff? So we're looking for t. And what is the speed just before hitting? So let's start with just finding those two. So we're looking for the final velocity, the velocity just before hitting. And that will be what it is right here. And the other thing we know is that we are 70 meters high. And let's decide which way we're going to make positive. In this case, it probably makes sense for up to be considered positive. So I'm going to draw my axis. And I'm going to say that plus y points up. All right, what do we know? Well, we know our initial velocity is 12 meters per second. This is under free fall the whole time. Gravity is the only thing acting on it, so my acceleration is negative 9.8 meters per second squared. I know it's negative because I defined v as positive. I'm sorry, I defined up as positive, and I know that gravity always points down. Okay, what else do we know? Well, over the whole time, we know that my delta y is going to be a negative 70 meters. Why is it negative? Well, I end up below where I started. Oops. Okay. Now, here's the problem. You could, let's start this. We should have enough information now to find at least the final velocity, right? So we can use ain't got no time. V squared equals V naught squared plus 2a delta y. We solve this for a. Sorry, no we don't. We solve it for v. So v is the square root of all this, plus or minus. So you've got 12 meters per second squared plus 2 times negative 9.8. And you'll notice that your negatives end up canceling here. Negative 70. Oops. Can you see that there? All right, so I do that, and I think that I get... Let me find that in my notes. I believe that I get a negative. It's plus or minus, but remember, plus doesn't make sense because I'm going down. So my answer is going to be a negative 38.9 meters per second. That's half the problem. Now, the difficult thing is going to be finding time. Now, what you could say is using my knowns and unknowns. Well, as a matter of fact, now that I have my final velocity, I should have enough information to find my time. So if I say Faithful. Wrong one. Old Faithful is just AT. Then T is going to be V minus V naught divided by A. I think you're going to get, if you plug all that in, I believe you're going to get 5.19 seconds. So now, what makes this one difficult is two things. First of all, if you tried to find time first, you got a really ugly looking quadratic formula equation. It was a quadratic, it had a t and a t squared. It was going to be difficult to solve. You can solve that, but it's going to be difficult. If I can find my final velocity first, pardon me, I can use this Old Faithful to find the time. Now there's actually a part C that says what's the total distance that the ball traveled? Well, do we know that? I don't know that we do, because all we know is that it went down 70 meters, but that's the displacement. So the next question is, what is the distance? So if you don't mind, I'm going to clear this here. Let's copy this and make a new page. And we'll paste this so that we can do, if I can get all that junk to go away. There we go. All right, so now we want to find the distance. So we know that the displacement's negative 70, but we don't know the distance. We do know that from here to here is 70 meters, but we don't know how high up it went. So what do we know about it going up? Well, remember, we know that at the top there's a split second in which the velocity is 0 meters per second. So we can solve another problem here, which is how much time does it take, or sorry, not how much time, but how much distance have you gone, how much displacement have you gone when your final velocity is 0 meters per second and your initial velocity is 12 meters per second and your acceleration is negative 9.8 meters per second squared. And I think that this is a job for Ain't Got No Time. Delta y equals v squared minus v naught squared divided by 2a. So you plug that in. I think that you're going to end up getting 2.15 meters. No, I'm sorry, I'm looking at the wrong question. Sorry, 7.3 meters. So now that doesn't answer the question though. The question was, what's the total distance? Well, I know I went 7.3 meters up. I know I went 7.3 meters down, and then I know I went an additional 70 meters. So I'm going to have basically 7.3 plus 7.3 plus 70. So my distance is going to end up being 79.5 meters. Okay. So what this, by the way, this video is going to be posted on Schoology. So if you need to view it on your own more slowly, please feel free to do that. I encourage you to do that. Take the rest of the class here to go over with your group to see if you can get help from your partners about any questions that you had on the homework. I will take some time in class on whenever I see you next to take whatever questions you have. Then I've got a review activity that we'll do because the following class, so on Thursday, will be your test. Again, please feel free to peruse this, ask your friends for help, and we will talk about this again when I see you next time.